In this video, we want to take a look at what happens when we have a binomial model, but n, the number of trials, is very, very large, and how we can then instead use a normal model, which we're very familiar with. So here's an example. The Tennessee Red Cross has 32,000 donors and needs at least 1,850 that are O negative. Assuming that the probability of O negative is still 0.06 that we talked about before, will they run out of donors before they reach their goal of 1,850? Now, this is a Bernoulli trial. It's still success O negative, failure not O negative. But these numbers are huge. And if we had to do this by hand, it would be absolutely asinine. It would be ridiculous for us to figure all of this out, because we would have to say, what's the probability they get exactly 1,850, and then 1,851, all the way up to 32,000. And so instead, what if we look at the binomial model, and because n is so large, remember n is 32,000. And because n is ginormous, what I'm going to do is I'm going to use my binomial model and find the mean and the standard deviation, which will make it turn into a normal model. And a normal model we're very familiar with. So the mean of a binomial model says take n times p. So out of 32,000, how many do I expect? Well, 32,000 times 0.06 is 1,920. The standard deviation, again, this is just a formula. The formula says take the square root of NPQ. So n is 32,000. P is the probability of success, 6%, 0.06. Q is 1 minus 0.06. And I get 42.483. So what I'm going to do is, because n is so large, I'm going to look at this as the normal model of 1920, 42.483, and I'm going to use things that I know how to do, like find a z-score, and use that to find the probability. So again, as we progress throughout the rest of the course, we're going to look a lot at the normal model. We're going to look a lot at different probability models and look at them as the normal model. Now, in order for us to use the normal model, two conditions must be met. First of all, the sample must be smaller than 10% of the population, so that's that 10% rule again. And we need to have at least 10 successes and at least 10 failures. And remember, we only do this when n is large. So if n is small, then we're still just going to go to stat calculator's binomial and use the binomial model. But because n is so large, 32,000, and it does meet both conditions, then I'm going to use that normal model using the mean of 1920 and the standard deviation of 42.483 that I found on the previous page. So now what we're looking at is we're looking at the normal model, and we know in the normal model I can find a z-score, and the z-score is the observed of the 1850 minus the expected, which is of course the mean from my normal model, 1,920, divided by the standard deviation, which we found to be 42.483. That gives me a z-score of negative 1.6477. Now this time in StatCrunch, I go to stat calculators and not binomial, because now I'm looking at a normal model. Because it met those conditions, here I would change the x to negative 1.6477, and again I'm looking at less than or equal to, and I compute to get 0.0497, etc. So will they run out of blood, or will they run out of donors before they get to their goal of at least 1,850 donors of O negative? Well, there's about a 5% chance that that's going to happen. Now, what would have happened if I didn't go through and do the normal model? What if I just went to Stat Calculator's Binomial? N is 32,000. P is 0.06. And I'm looking for less than 1,850, so less than or equal to 1,850. And notice that I get almost the same solution. So it still rounds to that about 5%. So the question is, when's it better to do it which way? The only time you are ever going to use the normal model for binomial is when n is large. So notice how large n is here, 32,000. That's when you use the normal model.